During World War II, over 1 million vehicles across Europe ran on firewood. Not as an experiment, as standard national transportation policy. Exposed to air supply, entire countries kept their economies moving on wood gas when petroleum vanished. The United States government published the construction blueprints in 1989, report number FEMA P-313. It is still publicly available today. You can download it right now. Gasoline costs $4 to $6 a gallon, more during any supply disruption. The fuel for this system is wood, harvested, scavenged, or stockpiled at zero cost. The device that makes this possible can be built for $100 to $300 in hardware store materials, and the Department of Transportation's regulations make it effectively illegal to drive on public roads. By the end of this video, you will know exactly how it works, why it was buried, and how to build one. To understand why this was erased, you have to see how big it actually was. This channel exists for one reason. The information that matters most for your independence is the information no one is paid to teach you. That is not an accident. When a technology threatens no existing revenue stream, no corporation funds its research, no university builds a department around it, no government agency promotes it. It simply disappears from public awareness, not through conspiracy, through neglect, through the quiet economics of irrelevance to profit. Wood gasification kept an entire continent mobile during the worst supply crisis of the 20th century. Then, cheap petroleum returned and every incentive to remember it evaporated. This channel recovers that kind of knowledge. Proven systems, documented results, technologies that work outside the supply chains you are trained to depend on. If that matters to you, subscribe. Not as a favor to me, because what comes next in this video, and every video after it, is built for people who would rather know than hope. Let's go back to 1939. When Germany's access to petroleum was cut off during the war, the response was not panic, it was engineering. The German government mandated the conversion of civilian vehicles to wood gas operation on a massive scale. By the mid-1940s, over 500,000 vehicles in Germany alone were running on gasifier units. Trucks, buses, freight haulers, agricultural tractors. These were not backyard contraptions. They were manufactured, standardized, and supported by state-level logistics. Fuel wood depots were built along major roadways. Technical manuals were printed and distributed to mechanics. The dominant design was the Imbert downdraft gasifier, developed in the 1920s and 30s by a French engineer named Georges Imbert. His design won out across the continent for one reason. It cracked tar internally. The self-cleaning properties of the downdraft configuration meant the gas it produced was clean enough to run an internal combustion engine without destroying it within days. Sweden tells an even more striking story. A nation that had almost no domestic petroleum supply converted approximately 73,000 vehicles to wood gas operation. At its peak, 90% of all vehicular traffic in Sweden ran on gasified wood. 90%. That is not a fringe technology, that is a national transportation infrastructure. France converted roughly 65,000 vehicles. Finland converted 43,000. Across occupied and neutral Europe, the numbers are staggering. State governments printed operator manuals. Mechanics were trained in gasifier maintenance as a standard vocational skill. Fuel wood was graded, sized, and distributed through organized supply chains. This was not improvised survival. It was industrial-scale deployment of an alternative fuel system that worked reliably enough to keep nations functioning during total petroleum deprivation. And then, within a few years of the war ending, every single one of those gasifiers was removed. Not because they stopped working. Cheap petroleum flooded back into European markets after 1945. The economic calculus flipped overnight. Why maintain a gasifier and haul wood when gasoline was abundant and inexpensive? The infrastructure was dismantled. The skills were forgotten. Within a generation, the entire chapter was erased from public memory. But the engineering never stopped being valid. The physics did not change. The chemistry remained exactly the same. Now, what I have covered so far barely scratches the surface. If you want the complete technical library behind this technology and dozens of others like it, the vault is where that lives. It is organized by category: emergency fuel systems, off-grid electrical generation, water purification and storage, long-term food preservation, field expedient medical knowledge, no filler, no repetition, just the documented methods, sourced and organized for people who act on knowledge instead of just collecting it. The link is in the description, but stay here, because what comes next is how this actually works at the molecular level and why the United States government confirmed it. Now let's talk about what is actually happening inside that metal box on the back of the truck. The process is called pyrolysis. When you heat organic material to extreme temperatures in a low oxygen environment, it is not burned in the conventional sense. It decomposes thermally. The long-chain carbon molecules in wood break apart. What comes out is a mixture of combustible gases. This mixture is called producer gas. Its primary components are carbon monoxide, hydrogen, and methane. The chemistry is not experimental. It is settled science. It has been studied extensively in academic biomass energy research for decades. The temperature range for effective pyrolysis is 700 to 1200 degrees Celsius. At those temperatures, with restricted airflow through calibrated nozzles, wood does not combust. It gasifies. Here's the operational sequence. Wood chunks go into a sealed hopper at the top. A fire is ignited at the hearth zone. Air enters through precision-sized nozzles, but not enough air for full combustion. The restricted oxygen forces thermal decomposition instead of burning. Hot gas rises through the fuel bed, cracking the tars that would otherwise foul the system. This is why the downdraft design matters. The gas passes downward through the hottest zone, which breaks apart the heavy tar compounds before they can exit the unit. The resulting gas flows out through a pipe, passes through a cooling system to drop its temperature, then through a filter to remove particulates. The clean, cool gas enters the engine's air intake through a mixing valve that blends it with ambient air at the correct ratio. The engine runs. Now here is where it becomes institutional. The United States government did not just study this technology. They published the blueprints. For you. In 1989, the Federal Emergency Management Agency released a document titled Construction of a Simplified Wood Gas Generator for Fueling Internal Combustion Engines in a Petroleum Emergency. Report number FEMA P-313. It provides a complete set of fabrication blueprints for a stratified downdraft gasifier designed to be built from commonly available materials. It is explicitly framed as an emergency preparedness document for use when normal fuel supplies are unavailable. It remains in the public domain. You can find it, download it, and read every page today. That is a federal agency telling you this works and showing you how to build it. So a federal agency published the construction plans, and another federal agency made it illegal to use the result. This is the part no one talks about. The Department of Transportation, through the National Highway Traffic Safety Administration, administers the Federal Motor Vehicle Safety Standards. These standards govern every vehicle legally permitted on public roads in the United States. They define requirements for fuel systems, emissions, crash integrity, and a long list of other specifications. Every one of those fuel system standards was written around petroleum-based fuel delivery, gasoline, diesel. The regulatory architecture assumes a specific type of fuel, a specific type of storage, and a specific type of delivery mechanism. A wood gasifier is none of those things. No federal statute names wood gasifiers. No law specifically bans them. The prohibition is structural. Any modification to a vehicle's fuel system that has not been certified through the FMVSS framework renders that vehicle non-compliant for road use. A gasifier is, by definition, a non-certified fuel system modification. You cannot register it. You cannot pass a federal safety inspection with it. You cannot legally drive it on public roads in most jurisdictions. One federal agency says, build it when you need it. Another federal agency says, you cannot legally drive it. No public policy document reconciles these two positions. That is not a claim. That is a verifiable fact you can confirm by reading both documents yourself. Now, I want to be clear about the framing here. Now, whether this contradiction represents deliberate institutional suppression or simply bureaucratic inertia is a matter of interpretation, and I will flag it as such. What is not speculation is the economic architecture surrounding it. Petroleum is the backbone of federal fuel excise tax revenue. The automotive industry's business model depends on vehicles designed around petroleum-based fuel systems. Foreign policy commitments spanning decades are structured around petroleum access. A technology that lets someone drive on wood collected from their own property generates zero tax revenue, zero fuel sales, and zero dependency on any supply chain. It is reasonable to observe that no powerful institution has an economic incentive to promote this technology. Whether that constitutes active suppression or passive structural neglect, you can judge for yourself. But here is what is not debatable. A technology that kept an entire continent mobile during the worst supply crisis of the 20th century is not taught in schools. It is not in mainstream survival manuals. It is not in any current federal emergency preparedness plan. FEMA published the blueprints 37 years ago and never incorporated them into active emergency planning. That gap is real. The reasons for it are worth your scrutiny. And private land use remains unregulated at the federal level. Agricultural exemptions may apply in some states for farm vehicles. Stationary use, powering a generator with a gasifier, is generally unregulated federally. The legal constraints apply to public road use specifically. If you are the kind of person who wants to know what works before you need it, subscribe. This is what we do here. Every video, documented, sourced, built for people who prepare while others scroll. Now let me be direct with you about the limitations, because this is where trust gets built or broken. Carbon monoxide is the primary hazard. Producer gas contains a significant concentration of carbon monoxide. It is odorless. It is lethal. During wartime use, CO poisoning incidents were documented, particularly in enclosed spaces and during cold weather operation where drivers sealed their cabs. This is a serious and non-negotiable safety concern. The system must be airtight from gasifier to engine. Operation must be outdoors or in extremely well-ventilated spaces. This is not optional. Power output drops. A gasifier-equipped engine produces roughly 30 to 40% less power than the same engine running on gasoline. The energy density of producer gas is lower. The engine still runs. It still moves the vehicle. But you will notice the difference, especially under load or on inclines. Tar maintenance is ongoing. Even a well-designed downdraft gasifier produces some tar. Filters must be checked and cleaned regularly. Neglect leads to engine fouling. Startup is not instant. Expect 15 to 20 minutes from ignition to clean gas production. You will know the gas is clean when a test flame at the output port burns blue. In a sudden evacuation scenario, that delay matters. In a sustained grid-down situation, it is a manageable part of a daily routine. Fuel is bulky. Wood takes up far more space per mile than gasoline. You are trading energy density for energy independence. That is a real trade-off, not a flaw to dismiss. These are engineering constraints. They were known in 1942 and they are known now. Millions of drivers managed them daily for years. They are not disqualifications. They are parameters. Now, here's how you build one. The foundation is the FEMA P-313 design, adapted to the invert downdraft configuration that proved itself across a continent. You will need sheet metal, 14 to 16 gauge for the outer shell and hopper body, steel pipe fittings for the gas outlet, air inlet nozzles, and routing plumbing, a stainless steel grate for the hearth restriction zone, high-temperature gaskets rated for sustained heat above 800 degrees Celsius, standard mounting hardware, bolts, brackets, and angle iron for the frame. The unit mounts in a truck bed, on a trailer, or on a welded steel frame behind the vehicle. The hopper sits at the top. Below it, the hearth zone with calibrated air inlet nozzles, typically 4 to 6 nozzles arranged symmetrically, sized to restrict airflow to the precise ratio that produces gasification rather than combustion. Below the hearth, the grate supports the charcoal bed and allows ash to fall into a cleanout chamber. Gas exits the lower portion of the unit through an outlet pipe. It routes first through a cooling system. This can be a length of pipe exposed to ambient air, a radiator-style heat exchanger, or a simple coiled tube. The gas must drop below 100 degrees Celsius before entering filtration. The filter stage removes particulates and residual tar. A packed bed of cloth, fine mesh, or wood shavings works. The clean, cooled gas then routes to the engine's air intake manifold through a mixing valve. This valve allows you to blend gas and ambient air to achieve the correct fuel-air ratio. Operation is straightforward. Fill the hopper with wood chunks, size between 1 and 3 inches. Hardwood works best. Softwood produces more tar. Ignite the fuel at the hearth zone. Close the system. Allow 15 to 20 minutes for the gasifier to reach operating temperature. Test the gas at the output port. When the flame burns blue and steady, the gas is clean. Route it to the engine. Start the engine. Refuel the hopper every 30 to 60 minutes, depending on load and engine size. Total materials cost runs between $100 and $300. Every component is available at hardware stores and metal suppliers. The FEMA document provides exact dimensions, material specifications, and assembly diagrams. Step back and look at what you now know. A technology that powered over 1 million vehicles across an entire continent during the worst fuel crisis in modern history, engineered by a Frenchman in the 1920s, deployed at industrial scale by multiple national governments, or validated by settled combustion chemistry that has not changed in a century, blueprinted by the United States Federal Emergency Management Agency in a document you can download in the next 60 seconds, structurally regulated out of legal road use by a federal safety framework written exclusively around the fuel industry it bypasses, and buildable for the cost of a tank of gasoline. The fuel is wood, the cost is labor, the plans are public. The only barrier between you and a vehicle that runs on a fuel you can harvest from your own land is a regulatory architecture that no one in power has any financial incentive to change. Now you know it exists. Send this to someone who needs to know, because this technology survived a world war. It can survive being forgotten, but only if people like you refuse to let it disappear again. Next week, we are covering another system the preparedness world ignores, one that turns a single car battery into something far more useful than starting an engine. Make sure you are subscribed so you do not miss it.